All right, everybody can hear me? I think it's time to get started. Thank you for being here at this late hour in the day. I know it's been a long day for you. We are here between myself and Khurram to talk about the capabilities of Windows Universal Platforms and how these applications can extend Cortana. And we are also here to talk about how the speech platform in Windows 10 has evolved and how you can enable speech inside your applications. If you remember the Viber demo in Joe Belfiore's keynote, where Joe was asking Cortana to send a message on Viber, and if you'd like to know how to do something like that, then you are in the right place. So Cortana in Windows 10 is running on a wide range of devices, anything from desktops, tablets, to phones. And on these devices, users have access to system capabilities through voice or text commands. For instance, the user can say to Cortana, hey Cortana, set a reminder or send an email, call or text somebody. But how about the scenario where the user can ask Cortana to do something with your app? For instance, the user can ask Cortana, hey Cortana, what's up with Jonas on Facebook? Or create a Pandora station, or message somebody on Viber, or tweet something. All of that is possible when applications take advantage of the developer opportunity that Cortana presents. When you integrate with Cortana, you will differentiate your app and you will delight your users by making the application's functionality available for users to access using natural language. Cortana is a front-end center experience in Windows 10, and you will increase engagement when users can launch and deep link into the application's pages from that central experience. You can make your users more productive by allowing them to get things done quickly with a simple voice command. And you can increase discoverability for your app. When the user is asking Cortana, what can I say? Cortana is going to present your application with a list of voice commands it supports. So all of that is simple to implement and is fun to implement. So let me show you how you do it. There are three topics I'm gonna cover today together with Khurram. The first two topics are about voice commands in the foreground for Windows Universal apps and for web-hosted apps. The second one is about speech recognition inside your app. This is where I'm going to show you how to enable interactions using voice. And Khurram is going to talk about voice commands in the background, and he's going to show you how to complete tasks using Cortana's Canvas and Cortana's voice. So with that, let's jump right in and talk about voice commands in the foreground. In Windows 10, Universal applications can register voice commands for users to direct at Cortana. And Cortana takes that input, and she redirects it to the application to take action and to do what the user asked. This functionality is available on all devices where Cortana runs, and is available to Windows Universal applications written in XAML and JavaScript. So with that, I want to show you a quick sample, a demo for the AdventureWorks application. This is the sample application that we wrote, and it's also available for you to download from the internet. First, I'm going to launch the application from the start screen to show you what is the user experience when the application is launched normally. It's a simple app. It manages trips. And notice here that if I want to see the details for a given trip, I'll have to select the trip and go to the page with the trip details. Now, I want to show you how to launch into AdventureWorks with the voice command from Cortana. So in Cortana, I'm going to say, AdventureWorks, show my trip to London.
Sure, showing trip to London.
So what happened there was Cortana identified Adventure Trip as the application to launch. She gave audio feedback to the user saying, sure, showing trip to London. And the application got back the voice command, and based on that voice command, decided to land the user on the details page for the given trip. So this is a quick and simple example of enabling voice commands in the foreground. Now let me take you back to the presentation. to see how that works. What I have here is a high-level architectural diagram where in the center we have Cortana running on the device with access to the Windows speech platform on device and also with access to the Microsoft speech recognition service in the cloud. On the right-hand side, we have the application, which needs to author a voice command definition file. This is an XML file which has the commands, literally the words that the users can say to Cortana for that particular application. When the app runs in the foreground, it needs to register the voice command definition with Cortana. And Cortana supports multiple system commands. And in this case, the command and the intent is a voice command. This is how Cortana associates the voice command definition with a voice command. The application can go away, and at a later point, the user can give Cortana a command. So in this case, I'm using the exact the example that I used in the demo. So the user says, AdventureWorks, show my trip to London. Cortana routes the audio to the speech recognition systems on device and in the cloud. These work together to identify what the user said. The recognized words are being sent to Cortana with the intent set to voice command. And at that point, Cortana identifies which application to launch. The application is being launched in the foreground, and Cortana passes the recognized string. Based on that string, the application decides to which page to navigate. So in this case, it navigates to the details page for the trip I asked for. To enable voice commands in the foreground for Windows Universal apps, you require to do three things. The first thing, you have to create the voice command definition. Then you have to register the voice command definition XML with the application, with Cortana at the application startup. And then you have to handle the voice command activation when the app is being launched from Cortana. So let's see how you author the voice command definition. The first thing you have to determine is what are the tasks inside your app which are valuable enough for you to consider making accessible from Cortana. And for each task, you have to determine what are the words that the users say in the context of that task. And you have to make sure that the words and the task functionality go well together. The other thing to keep in mind is that users say things differently. So for a command such as start a chat with Jonas in a messaging application, you might want to provide an alternate way of giving the command, such as send the message to Jonas. So the voice command definition allows you to specify different alternates for the same command, and we recommend that you take advantage of that. Next, you have to determine what Cortana should say to the user as she's launching the application. In the demo before, Cortana was saying, OK, showing trip to London. So that feedback that Cortana gives to the user is controlled by what you place inside the voice command definition. So make sure that the feedback is relevant in the context of your voice command. Once you determine the Cortana feedback, you have to pick an example for Cortana to show when the user is asking, what can I do for that application? And that example needs to be the most meaningful in the context of your different choices for saying the command. And that is important because this is how users will learn and know what to say to the application. When users give commands to Cortana, Cortana expects the application name to be part of the voice command. This is how she knows to launch application A and not application B. So by default, Cortana assumes that the voice command starts with the application name. So I have here a few examples. For instance, Viber, start a chat with Jonas, or Facebook, WhatsApp with Jonas. And also by default, Cortana will use the application's display name. In few cases where the display name is long, or it has special characters or numbers, or you simply want to come up with a shorter form, you have the option to specify an alternate name for Cortana to use. And the example that I like to give people is Skype for Business. You don't want the user necessarily to have a command where they say, Skype for Business, call somebody. Just providing just Skype is good enough, and it's a better option for the user. Or link 2014. So in that case, the application name that Cortana could recognize can be just link. So the bottom line is that you have the option to optimize the way the name is being used by Cortana and to make this name relevant in the context of your application's brand. Additional guidance for voice commands. First, keep in mind that you have the ability to make the voice command sound natural. I mentioned before that the application name by default is specified in the beginning of the voice command. So something like Viber start a chat with Jonas sounds pretty good, but keep in mind that Cortana can be launched with Hey Cortana. So in that case, the voice command could sound, Hey Cortana, Viber start a chat with Jonas. So to make the command sound natural, you have the ability to specify the application name at the end of the voice command. So in this case, you can enable start a chat with Jonas using Viber or WhatsApp with Jonas on Facebook. In addition to that, you have the ability to specify the exact position of the application name inside the command. So you can enable something like show my AdventureWorks trip to London, where AdventureWorks is the name of my application. So you have the flexibility of placing the application name inside the voice command to make the command sound most natural. In addition to that, you have to pay attention to the string that the user needs to say to Cortana. And you have to make sure that that particular phrase is phonetically rich enough. Something like start a chat with Jonas is better than get Jonas. Will have a greater chance at being recognized. How will you know whether what you provide is phonetically rich enough? We will tell you that when you register the voice command definition, if we detect that the recognition is likely to fail or to confuse the command with other commands on the system, then the API is going to fail, and that's how you know that you have to go and adjust the phrase. And then the last word of advice is avoid using Cortana's reserved commands, such as call, text, start. There is a longer list. This list is available on MSDN. And if you have to, because these names make sense in the context of your application, the option that you have is to author the voice command where you place the application name as a prefix. So in this case, Viber text Jonas, I'm on my way, is not going to be confused with, hey, Cortana, text Jonas, I'm on my way, because the intent was clear that the voice command was directed at Viber. Once you have the voice command definition, XML, you have to register that with Cortana. To do so, you invoke the Voice Command Definition Manager API. This is part of the Windows Application Model Voice Commands namespace. This is a new namespace that we've added in Windows 10, which has the APIs required for Cortana integration. And keep in mind that you have the option to update the voice command definition at runtime. In our case, we started with a short list of destinations that we provided Cortana as a vocabulary to recognize. But as the user is using the application, they can generate new data or they can delete data. And you have the option to update the voice command definition to have that in sync with your application's data. The last step is to handle the voice command activation. To do that, you need to overwrite the onActivated method on the application object. And keep in mind that onActivated is being called every time when the application is launched with a contract. So if the application is launched from a tile or from a push notification or as a shared target, or when it is launched from Cortana. So here, to make sure that you've been launched from Cortana, you need to check the activation kind against voice command. So if it is a voice command activation, in that case, you can cast the event args to voice command activated event args, and you get access to the speech recognition result. And from there, you can determine what the user has said. Based on that, you determine to which page to navigate, and you continue the interaction in the foreground. So with that, let me show you the code that we wrote for AdventureWorks. Basically, this is the walkthrough for the demo that we've seen before. So this is the AdventureWorks project. The first thing I want to show you is the voice command definition. Here we have the command set, which is the collection of voice commands for this file. Notice that it is authored in English, and you have the capability of localizing the voice commands in all Cortana supported languages. It has the application name. It has an example. This is what Cortana shows when the user is asking, what can I say? And then this is the command that I demoed to you. This is the show my trip to London command. This one, the command name, is the command identifier. This is how I know at runtime which command was identified. This is another example for this particular command. And then here I have two listen for elements. These are that holds the words that the user needs to say for that command to be recognized. They are different because the first one requires the application name to be used either before or after phrase. So this is how I enable the voice command to sound naturally by saying that the application name can show either at the beginning of the voice command or at the very end. The second listen for specifies the position of the application name inside the voice command. So this is what enables me to say something like, show my AdventureWorks trip to London. And destination here, this is a phrase topic. Sorry, this is a phrase list. And it has here the items, the vocabulary of words that Cortana identifies. And this list is something that you have access at runtime to modify, to add or remove destinations. So going back to the command, there are two more elements I would like to highlight. The first one is the feedback element, which is the audio feedback that Cortana gives to the user as she's launching the application. And the last one is the navigate element, which is important because this is how Cortana knows to launch the application in the foreground and not in the background. And with that, I want to show you how to register the voice command definition. What I have here is the code on the application object. The onLaunch method here has the code that creates the root frame. There is nothing special about this code. Most of you have seen this before. What I want to show here is that after the window, the current window is activated, we come and we create a storage file that is pointing to the AdventureWorks commands.xml. And then we pass that storage file to the voice command definition manager, and we call install command definitions from storage file async. So that's all it takes to register the voice command definition. You can call this once when the application runs for the first time, and you can decide not to call it again. Or you can call it every time when the application is launched. Keep in mind that if you update the voice command definition at runtime, you will have to call this method to make sure that Cortana picks up the updates. And the last method I want to show you here is the onActivated method. Notice here how I checked that the activation kind is voice command. And that allows me to cast the command arguments to voice command activated event args. That gives me access to the speech recognition result. From there, I can tell which command was invoked. I can tell what the user has spoken. I can tell how the user gave the command, whether the command was input through text or through voice. And here, for this particular command, I get access to the destination phrase list. Basically, this is what tells me whether the trip was London versus other destination. I create the view model that I'm going to pass to the page. This is specific to this application. This is code that you will likely modify to do something meaningful in the context of your app. And here, I set the navigation page to trip details. Later on, I create the root frame if it's not already there for me. Nothing special about that. And then the last thing I do, I call navigate on the root frame, passing in the page, the selected page, in this case, the trip details, and the navigation command object, and I activate the current window. So this is what it takes to implement voice commands in the foreground for Windows Universal apps. So with that, let's move on to talk about voice commands for web-hosted applications. As you already know, in Windows 10, websites can be submitted to the Windows Store. And for such applications, if they do the work to create a voice command definition and register and take a few steps to register that voice command definition with Cortana, then Cortana is going to launch these applications with voice commands. The same voice command definition schema applies for web-hosted applications, and the same activation model applies as for JavaScript Windows Universal apps. So let me show you how this works at the very high level. The diagram looks similar, except in this case, notice that the application needs to create the voice command definition file, and instead of making it part of the package manager, the voice command definition file is being stored somewhere on the website. It can be on that particular website, or it can be on a web service. And in the package Apex manifest, the author will have to set the start page to the URL of the website. And in addition to that, it needs to specify a rule which gives access to that website to run code which is part of the Windows runtime on the device. And that is needed because the JavaScript coming from that website will have to write code to access the speech recognition result when the application is activated. On the default HTML page for the website, you have to specify the meta element set to ms application-cortana VCD. And there you have to provide the URL for where the voice command definition file has been placed. When the application runs in the foreground, the registration happens, and Cortana will learn about the voice command definition for this web-hosted application. Later on, the application goes away, and then the user can give Cortana a command. Cortana will take the audio and route it to the two speech recognizer engines. They work together to come back with a recognized string and the voice command for Cortana. Cortana is launching the web application, which at this point, it loads the default HTML page. And on that page, which has the JavaScript code for the application activation, so at that point, that code is running. And notice here that this code looks very familiar with the code that you have to write for a JavaScript universal application. So here you have to handle the activated event, and you have to check that the activation kind was for a voice command, and that gives you access to the speech recognition result, and from that point onward, you decide to which page to redirect. So this is how it works at a very high level, and these are the 3 steps required to enable voice commands for web-hosted apps. First, you have to create the voice command definition file and host it on the web service. Then you have to register the VCD on the default HTML page using the meta element. And then you have to handle the voice command activation in JavaScript on the default page. And with that, I would like to show you a demo. So what I have here is Windows Universal app, which I created for JavaScript. And I will ask you to ignore anything else in this project because it's not relevant, except the package Apex manifest. In the manifest, I set the start page to the URL of the website that I want to host inside the application. And as I mentioned to you before, here, I set the rule to indicate that this particular website can access code and run on the Windows runtime on the device. So that's all it takes for you to create a web-hosted application. And now looking at the website itself, I want to point here that the website, let me find it. The website has the meta element for ms application-cortana VCD, and it points to the URL where the voice command definition XML has been placed and authored for this website. And in addition to this, the page has a bunch of JavaScript code. The one which is interesting is the scripts app.js, and this is where the JavaScript code is placed for handling the voice command activation. I can show you the JavaScript code here in IE, but it's even better if I show that to you in Visual Studio. So from here, I will try to run the application for the registration to happen. And if you notice in the Solution Explorer, Visual Studio pulls the JavaScript from the page that is being loaded in the web-hosted app. So here I have the app.js file, which I'm going to try to open. And I will not attempt to read this to you or ask you to read it, but I will try to find here come on. I will try to find here the code that actually handles the voice command. So let's see if I succeeded. So there it is. This is the activated event, and the code goes on. It's not readable. We will not attempt to understand what's going on here. The point here is that the website has Java code that takes care of the activation. The interesting part here, which is worth mentioning, is that you can set breakpoints, and you can actually debug when this code is running on the machine. And with that, I will attempt to do a demo for this particular web-hosted application. So let me give it a try. Let me try one more time. I wasn't prepared. Flight Arcade, start at level gold. Okay. One more time. I'm feeling lucky. Flight Arcade, go to waypoint Bravo.
Going to problem in Flight Arcade.
Okay. It didn't quite work, and I will not try to make it work. But anyway, it tries to please me, so somehow I'm going to play this game. Anyway. Okay, so with that, let's go back to the main presentation. And let's talk about speech recognition in your app, in your Windows Universal app. So when Cortana is launching Windows Universal apps, the application has access to the speech recognition result. And through that object, it can tell whether the command was input through voice or through text. If the command was input through text, then continue the interaction with the user silently. But if the command was input through voice, then consider interacting with the user using speech. You can use Windows Media Speech Synthesis APIs to talk to the user. And new on Windows 10, we are making the Windows Media Speech Recognition APIs available to Windows Universal applications. There are two scenarios that I want to highlight here for in-app speech recognition. First is the on-demand speech recognition. This is a short recognition session that typically starts when the user takes an action, such as the press of a button. And it lasts for about 15 seconds or for as long as the user speaks. And to start such a recognition session, you call either recognize UI with async, which will present the user with the system listening GUI, or if you want to provide your listening UI experience, you can call recognize async. The point here that I want to make is that when the recognition is in progress, you want the user to understand that the application is listening for what they're saying, and this is a privacy principle that we would like you to pay attention to. When the recognition gets started, you have to specify the grammars to be used by the recognition engine. So you can specify system predefined grammars such as dictation, web search, or form filling. And these are grammars stored online on the Microsoft Speech Recognition service. So when you use these APIs with the system predefined grammars, keep in mind that your device will have to be connected to internet to have access to the service in the cloud. You can also provide your own grammars, your own set of words to be recognized as a list of strings or as an sRGS file. In that case, the recognition happens on device, and the device doesn't have to be connected to the internet. The second scenario I would like to talk about is new in Windows 10. We allow you to create a continuous recognition session. This is where the application decides to listen continuous for the user's voice, and it is useful in scenarios such as long dictation, where the user can dictate for long periods of time. For that particular scenario, you need to use the online dictation grammar, and the device needs to be connected to internet. But you can also provide your own grammars for scenarios such as always listening for in-app commands. So imagine a scenario where on a given page, you want to enable the user to interact with the page using voice. So when the page is being loaded, you can create a continuous recognition session, and you can provide a grammar for the recognizer to use words such as take a note, save a note, go to the next page, and when the page is being navigated, then the continuous recognition session ends. The important thing here to keep in mind is that the continuous recognition lasts for as long the application runs in the foreground and for as long the application has focus. If one of these conditions are not true, then the continuous recognition session ends. Same as before, if you are listening for what the user has to say, you have to show the user that listening is in progress. So that's number one, because you want to respect their privacy. But also, you want to tell the user what they can say, because otherwise they will not know what are the voice commands interesting for that particular scenario. So let's look at AdventureWorks with in-app speech recognition. AdventureWorks, show my trip to London.
Okay, showing trip to London.
Take a note. Okay, try one more time. Take a note. Okay, we will try a bit of magic here and give it one more try. AdventureWorks, show my trip to London.
Sure, showing trip to London.
Take a note. Nope. Okay, one more time, and if not, I'm going to show you the code. It's better than nothing. Take a note. Bring an umbrella. Safe trip. All right. Thank you. Okay, so what happened there was when the page was loaded, I created a continuous recognition session, and I'm listening for two sets of words, take a note and safe trip. And notice here that I have a microphone icon, and I indicate to the user that the app is listening, and this is what the user can say. When the user says take a note, then I stop the continuous recognition session because I will start an on-demand session with a dictation grammar, which is going to let me input words into the text box. And then once I'm done with that, then I give the command safe trip just after I resume the continuous recognition session. And when the page is going away, then I stop the recognition session. And with that, I'm very proud that it worked. Let me show you the code. The code is in trip details XAML CS. So let me take you to Actually, I think I was right in the. OK, let me show you the two methods interesting here. I have onNavigated_to and onNavigated_from. And when the page is loaded and is being navigated to, I initialize the continuous recognizer object. When the page is navigated from, then I delete the continuous recognizer, which also stops the recognition session. So let's look at initialize continuous recognizer. Here, I create a speech recognizer, and I provide the list of words for the speech engine to recognize. So I'm looking for two sets of commands, take a note and save trip. I compile the constraints on the grammar. I set the callbacks on the completed and results generated events. These are the events which are being raised when either the speech has completed or when the engine recognized my words in the grammar, and I'm being called back every time when these words are being recognized. And then last thing I do, I call start async on the continuous recognition session. I said it's the last thing I do, but I actually am doing more, and that is I make sure that the microphone icon and the text boxes that show to the user what they can say are visible, because I need them to understand that the application is listening, and they should know what they can say. Delete continuous recognizer will stop the continuous recognition session. I'm calling cancel async, and it will just dispose the object. There is nothing terribly interesting there. And this is the onResult_generated method, which is being called on the result-generated event. Here, I get access to the speech recognition result, and I test here to see whether I was called with take a note versus save trip. So when I said take a note, I come here and I cancel the recognition, the continuous recognition, because later on, I create an on-demand speech recognizer. And you should keep in mind that you can have only one recognizer active at a time. So that's why I had to cancel the recognition for the continuous recognizer. And here, the speech recognizer for populating the text box is using the dictation grammar. It's compiling that onto the grammar, and it calls recognize async. Notice here that because I provide my own UI to show to the user that the application is listening, I'm calling recognize async and not recognize with UI async. The recognition comes back after the user is done talking. And all I'm doing is to take the spoken text and place it into the text box. And with that, after I dispose the on-demand speech recognizer, I come here and I restart the continuous recognition session because I want to be able to say save trip or even take a note if I'm not happy with that particular note. And on save trip, all I have to do is to click the save button, and that did the saving for me. And with that, I conclude the demo for in-app speech recognition. So let's go back to the slides. So I've talked about voice commands in the foreground for Windows Universal applications and web applications. And I showed you how to enable speech recognition inside your Windows Universal application. Now I'm going to hand it to Khurram to talk about voice commands in the background.
All right. Thank you, Adina. So what you just heard about is how you can leverage Cortana and the speech platform to handle a voice command in your application, where your application is launched in the foreground as a result of the voice command. What I'm going to spend the next 30 minutes or so talking about is how you can seamlessly integrate with Cortana and handle similar voice commands in the background and surface those results of whatever operation you've taken back into Cortana's UI and that canvas. Now, if you saw Joe Belfiore's demo with Viber and him sending a message to Terry Myerson, or if you saw Ali's talk earlier in the same room where he did the demo with Pandora, that's exactly what we'll be talking about how you implement. So just for reference, how many of you saw Ali's talk earlier with Ed? OK, so a fair few of you. For the benefit of the rest of you who didn't, I'm going to do a very quick demo just to ground what we'll be talking about. When's my trip to Las Vegas with AdventureWorks? Let's give that one more try. The system's having some issues. Give me one moment. When's my trip to Las Vegas with AdventureWorks?
You have a trip to Las Vegas on Tuesday, February 2nd, 2016 coming up.
So let's take a moment to think about what just happened. I just asked Cortana a question that normally she would have no idea how to answer. But because I have the AdventureWorks application installed, the application was actually able to surface that information to Cortana. So the user asked a question, they got an answer back, and your application got the credit for it. And now the user can just move on with what they were doing previously. Or if they're interested, they could drill in for more details. So if they're interested in what that trip involves, they could click on that icon that your application is deep linked into, and you see the details associated with that trip. Now, you can also do slightly more complicated flows that involve a little bit more interaction. So let's try that. AdventureWorks, cancel my trip to San Francisco.
Which one do you want to cancel?
The one on July 6th.
Cancel this trip to San Francisco?
Yes.
Canceled the trip.
So there you saw a little bit more of an interaction. Cortana needed some information from me, and I was able to provide that, but I still have the choice of moving on with what I was doing previously. So no need for that. So the experience you just saw can be surfaced from any universal application, whether it's written in XAML or in JavaScript, provided that this application implements a background task. This background task is what's doing the heavy lifting and is providing the result back to Cortana. So let's take a look at the architecture that's involved with that. So once again, I'm sure you're familiar with this now. Everything starts with your application and the voice command definition file. So now you've specified that your application supports listening for some command. You registered that with Cortana. At some point in the future, the user comes along and says, AdventureWorks, what trips do I have coming up? So we leverage the Windows Speech Platform and the Microsoft Speech Recognition Service, and we recognize that this command is handled by your application. But instead of launching your application in the foreground, at this time, we launch that background task. And we're going to call it Voice Command App Service in this case. Now, this background task can take whatever operation is necessary to complete the command. I've included a couple examples here. If you've got a web service where you maintain these trips, you can reach out to that web service, pull down data, update the content on the web service. Or in the example you saw with Viber, you saw that little icon back in Cortana's canvas that a message had been sent to Terry Myerson. What's happening there is that the background task is just rendering XAML to an image and asking Cortana to render that back. Or if you want to keep things simple, you just update local storage or some settings related to your application. The point is, whatever it is you need to do, you can be doing in that background task. So when that work is done, you hand the results back to Cortana. So in this case, we've returned a result to Cortana saying, here are your upcoming trips. You're going to San Francisco on May 29th, and so forth. Now, steps 7 through 9 can actually be repeated multiple times, as you saw in the second demo. If you need more information from the user, or if you need to give them up-to-date progress information about the fact that you're canceling the trip, you can do that loop multiple times. So what's involved in actually doing this? Again, it's a 3-step process. Step 1, you define what it is you're interested in listening for. Step 2, you actually register that VCD file. And step 3, and this is where things start to differ, is you have to handle that voice command using an application service. So the only thing that's really different in the voice command definition file is the highlighted element here, which is the voice command service element. Now note that this is replacing the navigate element. Here, what we're really telling Cortana is that for this command, which is show my trip to San Francisco, in this case, I would like to handle it using the AdventureWorks service. Now keep that name in mind. It'll come in again. Now, once you've specified the command, you need to be ready to handle it in that background task. So what is an application service and how is it related to a background task? The background task is simply an object that a class in your project that inherits from iBackgroundTask, and it implements this method, the run method. This run method is what we call when we hear your voice command, and this is your cue to start doing the work that you need to complete the voice command. So what is so special about an application service in this background task? Well, in this scenario, you'll need to register the background task as an application service, and you'll call it the application service name equals AdventureWorks service. Now note that this is the exact same name that you specified in the voice command definition file, which is how Cortana knows that this is a service that actually does the work involved in updating trips. So when you're implementing a background task that completes voice commands, these are the namespaces that you'll be interested in. And I'll call out two specific classes in the application model voice commands namespace. The first is voice command definition manager. This is the class that you use to register your voice command definition file initially, and also the class you use to update the phrase list or update the voice command definition file at runtime. Now the second, more interesting class here is voice command service connection. This is your connection to Cortana when you're running in the background. So if you need something done or if you need some information from Cortana, voice command service connection is where you need to be looking. So let's take a quick look at voice command service connection. You can group the operations that voice command service connection supports into three categories. The first is making requests to Cortana. So if you need to ask the user for confirmation before you send $300 to somebody, this is the API you call. If you need to ask the user to select between one of n entries to disambiguate, for example, if they didn't specify who you want to send the money to or which trip you want to cancel, then you call request disambiguation async. Now, there's also scenarios where you're processing in the background and you decide, you know, it's better for me to continue this flow in my full-fledged foreground application. You can also do that by calling request app launch async. The second groups of tasks that you can do with voice command service connection are update-related tasks. So you're just reporting stuff to Cortana. So the first one is report progress async. So if you're canceling a trip and that requires a trip to your web service, and that can take more than a couple hundred milliseconds, then send some progress over to the user, let them know what you're doing. You can also report failure and success using these APIs. Finally, you can and should register for the voice command completed event. This event is raised anytime Cortana completes a voice command. So voice command could be completed because you called report success async and we told the user and showed them the results, or it could be completed because the user decided to cancel. So what sort of canvas interactions can you do from that background task when you call those various APIs? So the image here shows the set of interactions that are possible. You'll see that Cortana says something to the user, Cortana shows a string text to the user, and Cortana shows some content to the user. Now note that what she says to the user can be different from what is printed on the line. And usually what she's saying is a bit more colloquial. So in this example, you'll see Cortana saying, which one do you want to cancel instead of which one do you want to cancel. So that sounds a bit more natural when she's doing text-to-speech on that string. Now, the voice command content area is what hosts the content tiles. Content tiles is whatever your data is associated with the voice command. So in this case, with the AdventureWorks application, a content tile represents a trip. So in this case, we'll see the destination and the image of the destination and the date associated with the trip. So how do you control what's on the canvas? You do that by using the voice command response object. The voice command response controls the voice command user message. What would you like Cortana to tell the user? So that's a combination of what Cortana says and the string that's shown on the canvas. There's also a repeat message. So when Cortana is asking the user a question, for example, are you sure you want to cancel this trip? The user could say something that Cortana is not expecting to hear, like bananas. At that point, Cortana needs to ask the user again, like, are you sure you want to cancel? But we don't want Cortana to repeat the same question again and again and sound robotic. So that's why the repeat message is there, so that you can give an alternate phrasing for the same question. And then there's the content tiles, which are associated with each trip, and a launch argument. So if the user at any time decides to launch into your application, they can click on that link, and you have the ability to specify some context associated with this screen. So when the user taps that link, you'll know what they were doing and why they might want to launch into your application. Now, talking about a content tile, let's take a look at the anatomy. So you obviously have the title, a couple lines of text you can specify, a launch argument associated with the tile. So if the user taps a specific tile, you can also associate context with that tile, so that when your application gets launched as a result of that, you know that they tapped down Las Vegas, so you can do whatever it is that tapping on that tile should do, whether it's canceling or confirming. And of course, there's the image. How this data is laid out in Cortana's canvas is actually controlled by the voice command content tile type enum. And that enum controls whether that data is laid out in various text formats or if that's laid out in various formats using square images, tall images, landscape white images. So at this point, we know enough that let's take a look at the implementation behind the demo I did earlier related to when's my trip to Las Vegas with AdventureWorks. So as always, everything starts with the voice command definition file. So here you'll see when is my trip to destination. We're listening for when is my trip to Las Vegas. So, and we've pointed out that this command should be handled by the AdventureWorks voice command service. So what exactly is that? Because we said it's a background task, but what does that mean? So here's my Visual Studio solution. I've got the application. It's got the view model implemented. I've got the model separately as a project. And then here's the voice command service that's being invoked. So I'm just going to let you know how we got to this stage. All that's really required is go to Visual Studio Solution, add new project, and this is simply a class library. So you just add a class to your project, and in this case, you have to register from background task. So this is the run method that gets called when the application, when Cortana hears the voice command. How do we know that this run method should get called? Well, we registered this in the package manifest that you saw earlier. So here you see that registration saying that the application service, AdventureWorks voice command service, is implemented by this object. So once we're in this run method, again, this is just a background task, so you do the standard things like getting the deferral on the background task and registering for cancellation. You check that this is indeed running because of Cortana invoking the AdventureWorks voice command service. And the first thing you do is you create an instance of voice command service connection. Remember, this is your conduit to Cortana. This is how you talk to Cortana. Once you've got that connection, you grab hold of the voice command. So this is what I said. So that's what that represents. And in this case, we check the name of the command. And if the name is when is trip to destination, this is the name from the voice command definition file, we'll try to send completion message for destination. And this is a pretty simple implementation. We load up all the trips that we have in the store. And for each, for the trip that we're interested in, we create a message where the display strict is here's your trip, and the spoken message is you have a trip at this date. And we also create a content tile. And this is the enum I was talking about earlier. This controls how the content tile is laid out in Cortana's canvas. And in that content tile, we decide it's important for the user to know the destination and the date and have an image of the destination. This is the app launch argument that we referred to earlier. So when I tapped on that Las Vegas icon, that's how the application knew to bring me to the Las Vegas page. OK. Let's switch back. So what we just saw was one quick, one-shot answer. But we know that we can do more complicated flows. So if the user says, cancel my AdventureWorks trip, you need to know which trip. So at this point, using the same voice command response object, you can generate the screen, which is disambiguation. So now you're asking the question, which trip do you want to cancel? And you have two content tiles on this page. The user is welcome to select either one of those. Let's say the user says Vegas Tech Conference. Next thing you want to do is ask for confirmation using request confirmation async. That'll return a result back to your background task. And at that point, you'll begin canceling the trip. And that might take some time. So now you call report progress async and telling the user, all right, I'm canceling this trip. Hold on a second, and we have a progress bar generated there. And finally, you call report success async with the final result. Now let's take a look at some of these in a little bit more detail. So disambiguation is interesting. I want to talk a little bit about it. So when you ask the question, which trip do you want to cancel, the user has the option of selecting one of those entries by text, by tapping or clicking in the UI, or they have the option of using speech. Now, if they're using speech, Cortana automatically listens for any utterance that uniquely identifies one of those tiles. So what does that mean? Let's take some examples. So in this example, the user could say Vegas Tech Conference, obviously to refer to the first one, or they could say the first one. Or they could also just say the one on August 18th. Now, that is the detail related to the party in Phoenix. So that would do the same thing as tapping on party in Phoenix. Now, until the user makes a selection, the call to request disambiguation async does not return. So by the time the call returns, we guarantee to you, the application, that the user has made a selection. For confirmation, this is a relatively simple scenario, but one guideline I want to share is that before you take any destructive or irreversible action, please confirm with the user that they actually want to do that, especially if the flow is happening with speech. So progress. So if you're doing any sort of operation that takes more than a couple hundred milliseconds, you want to report progress back to the user. So we really recommend that you do that. The system that we have in place is relatively smart. So if you send several updates within a short period of time, we'll be able to coalesce those updates to make sure that the user doesn't get inundated with lots of flashing screens because you called report progress 20 times within 1 second. One thing to note here is that we do have a guard in place. If Cortana doesn't hear back from your background task for 5 seconds at any point, Cortana will time out the flow and close the operation. So please make sure that if you're doing anything that takes a long period of time, that you're calling report progress async. There are 2 more scenarios where Cortana may choose to insert a progress screen on your behalf. And I'll talk about what these scenarios are. In the first screen you see on the left, we would show this screen saying that your application is working on this when we don't hear back a response from your application initially for 500 milliseconds. That could happen because you do a lot of work before you use voice command service connection to talk to Cortana, or because your application is running on a really low-end device where just starting the background task took a decent chunk of that 500 milliseconds. Now, in this case, we give you the option of specifying the feedback element in the BCD. So if you have it, we'll say that out loud. But in the examples that you saw, you noticed that Cortana didn't show the screen. That's because that scenario executed in less than 500 milliseconds, so we didn't see the screen. Similarly, the screen on the right will be shown only after we give you a result for confirmation or disambiguation. So when the user has told you, yes, it's OK to cancel this trip, if we don't hear back from you with 500 milliseconds, we will assume you're working on it and show the screen to the user. And this screen will be smartly derived from the previous question that you asked. So if you ask which trip you want to cancel and the user taps on one, we'll say you're working on the one that the user selected. So in a summary, you can interact with Cortana from a background task using voice commands, and you can ask for confirmation or you can ask for disambiguation, and you should show progress. Now, what's the interaction flow in detail? So everything starts with the user saying, AdventureWorks cancel my trip. Cortana gets invoked, and it recognizes it's your background task, so we call the run method, and your application service runs. Now, at this point, I'm going to use the green bar here to indicate that this process currently has the flow. And I apologize at this point if you're red-green colorblind. At this point, you recognize that there's multiple trips, so you need to know which trip to cancel. You call request disambiguation async. Cortana asks the user specifies Las Vegas, and we return a result to you, voice command disambiguation result, with the content Las Vegas. You check that item, and you say to the user, are you sure you want to cancel? The user says yes, and we give you a confirmation result back. This is the time at which you start doing the processing of cancellation for a trip. And now note that the green bar is on the right-hand side, meaning that your background task has the flow at this point. So if you don't report progress in this time and 5 seconds go by, Cortana will cancel the flow. So you call report progress a couple times, and then you call report success async. And as part of reporting success, you can also show results in the UI. And remember, those results can have deep links. So as part of reporting success, we fired the completion event because everything went well, so you do any cleanup that you need to. Now, if the user at some later stage goes in and taps on that tile, and you have the deep link, we'll also go ahead and launch your application in the foreground. And I'm using the 2 different colors here to indicate background versus foreground. Now, what we saw earlier was a successful flow. Remember that if the user decides to cancel the operation at any time, you could receive the voice command completed event earlier in the flow. So please be prepared to handle that event even when you're doing processing in your background task. So at this stage, I think you know everything you need to author a little bit more of a complex flow. So let's switch back to the demo machine and see how we can extend this to handle a scenario where you want to share trip details with the user. So we go back to the voice command definition file. In here, we say that we want to add a command called share trip. Share trip is just listening for share trip details with contact. And here's a couple of contacts. You can update these later at runtime as well. Now, what we need to do is actually handle that command. So again, we're back in this run method. Here are the commands we already support, but we want to add another one. So we add a case statement for share trip. That's the new command we just added. So now we just need to implement this share trip with contact method. Now this method just, again, opens up our trip store, and for each trip in our store, it creates a content tile so that we can represent that trip in Cortana's canvas. There we show the destination, the description of the trip, the date, and here we associate the trip with the app context. Now we allow you to associate an arbitrary object with the voice command content tile so that you know what that tile represents, so that you can always translate back from that tile to whatever that tile represents. And you'll see why that's useful later on. Now, assuming there were multiple content tiles, multiple trips that you might want to share with the person, you'll have to ask the user, which one did you want? So again, we create a user message asking which trip. We create the disambiguation version of that message, and then we just call request disambiguation async. When this call returns, we know which trip the user wants to share with their contact. At that point, because sharing trip details involves sharing private information, we want to confirm that the user actually wants to do that. So we create another user message asking the user if they want to share the trip details, and then we call request confirmation async. Now, at this point, we know whether the user wants to share details or not. So the final check we do is, if they confirm, great, let's go ahead and do that. You add the code here to actually share trip details, and you call report success async saying, great, I got that done. So that's really all it takes. So let's see if this compiles and if this works. So there's the project. I'm going to deploy this and run the app once because I updated that voice command definition file, and this sample is registering that VCD file with Cortana on launch. So we just registered with Cortana. And one tip is if you want to check that your command registration went through, you can go to the help section here in Cortana and go down to your application. And here you can see the new share trip details with Sam example came up. So with fingers crossed, let's give that a try. AdventureWorks, share trip details with Travis.
Which trip do you want to share?
The one for the Build conference.
Would you like to share this trip with Travis?
Yes.
You're all set. Travis now has a copy of the trip details.
Now, that's really all it took to add a completely new scenario to this application. So to wrap things up, I'd like to share a little bit of guidelines. To author successful scenarios and high-quality scenarios, we recommend that you keep the conversation with the user relevant to the original intent they had with the voice command. Be clear and concise in your use of language, and please be transparent with the user at all times what you're doing on their behalf in that background task. So keep in mind that several of your users may actually be using your application in a different language locale. So just as you could use the voice command definition file to specialize commands for specific languages, at runtime in that background task, you can inspect a property on voice command service connection to identify which language you're actually working with right now. And then, unlike in the demo, please use resource strings to create the voice command user message for the right language so that you can send that back to Cortana. So as a recap, 3-step process: create the voice command definition file, register it, and then handle that, whether it's through foreground activation or background activation in a background task. How do you select which one? For complex tasks and long-running operations, we recommend that you do foreground activation that you saw earlier in this presentation. But for one-shot questions and answers, or for tasks that don't take very long and you don't need much information from the user beyond confirmation and disambiguation, we recommend that you use background voice command handling. And keep in mind that you can use this to also initiate long-running tasks so that the user can always come back and check on the progress. And if you're still not sure which one to use, just go with background handling, because you can always call request app launch async to launch your application in the foreground and get to the other scenario. So We hope you're as excited as we are, and armed with this knowledge, you'll go and build applications that extend with Cortana and leverage the speech platform capabilities. I've included some references here. You can go to the app services session if you're interested in more in background tasks and application services and how to debug those specifically. And you can also see a session on web-hosted applications. And please check out the AdventureWorks sample code. That's exactly what we've been using in this presentation so far. So please evaluate the session, and at this point, I'll take any questions that you have, and I'll be around here for a while so we can have a conversation. Thank you. Please go ahead and use the microphones to ask the questions. Are the microphones on?
Is it on? If you're using just in-app commands, is there still an issue with reserved words?
No, there isn't.
Do you have examples of custom grammars?
I'm sorry, did you ask about custom grammars?
Yes.
So the sample that we posted online contains that one example of the custom grammar, which is listening for take a note and save trip. So that's one example of a custom grammar. But you could load those in one of various ways, and we can talk a bit more in detail about that if you have a specific scenario in mind. So let's have that chat in a couple minutes. And you can also ask some of these questions tomorrow. If you don't have the time now, if you need to leave, then I'll be around, and some of my coworkers will be around at the experts booth tomorrow morning as well. But yes, there are examples. I just don't have pointers to them right now.
Is the app name a requirement in
No,
the definition?
it's not a requirement because Cortana will use by default the display name. But it's a recommendation in case where you need to make your application easier to pronounce by the user, for instance.
This is a little bit out there, but will Connect on Xbox be able to do similar things in the future with Universal Apps?
So in this session, we're focused on the Universal Windows platform and how third parties can integrate with that, leverage that and integrate with Cortana.
For desktop phone and tablets.
Okay, thank you.
Can you implement the foreground and background task and then decide what commands you want for the specific scenario?
Absolutely, that's exactly what this sample does. You saw some of the demos earlier where we said show trip to this destination that launched in the foreground, and then the other demos I did that handle background. So you're welcome to try one out and then switch to the other. It's relatively quick iterative process.
And you can decide that one command is using one background task and a different command is using a different background task. You have options.
So there's a tip there as well. If your application is pretty heavy, so it takes a while to load the application, you could always have the background task be relatively minimal and have that implemented as a separate project. So the load time cost you incur there is much lower as well.
What will happen when Apple name conflicts up other application?
So you're asking about the scenario where we have two applications with the same name on the system.
Right.
So in that scenario, Cortana will actually ask the user, before we proceed with launching the application or launching the background task, Cortana will ask the user which one of those applications they would actually like to use. So although it's a rare scenario, that will be handled by Cortana.
I see. So how to choose exactly application?
So you saw the example of Cortana asking which trip did you want to cancel? So we'll have a similar disambiguation process where Cortana will ask the user, which application did you want to use for this command? So remember, this will only happen if you have two applications with the same name with the same commands registered. So only then will you be in the scenario, and in that scenario, Cortana will ask which one of those applications you want to handle.
And Cortana is going to present the application icon, the application name. So it's going to be very straightforward for the user to identify which one.
Oh, I see. Thank you.
If there are no other questions, we'll transition over to the Windows Insider area. So feel free to come join us still if you want to discuss a couple more things in detail. Thank you.
Can I ask more questions?
Absolutely,
Sorry.
yes.
So do we really have to pay for using this kind of technologies? for example, if we use the Bing or Bing map, some kind of price is applied for each sessions, right? So I just wonder, those guys, we have to pay for this kind of technologies.
You do not have to pay to integrate with Cortana, but if your functionality requires using of a web service that is monetizing your usage, then that is independent of this functionality.
So the platform work that we've done, that we've showed, is available to all developers and comes without costs.
So do you have any ideas to apply this kind of technology to desktop applications?
Yeah, several. Did you see Ali's talk earlier today?
No.
Okay, so I'll cover some scenarios, but I also highly encourage you to go see that talk, because his talk was very demo focused and real life scenario focused. But personally, I would love to see this being integrated for any sort of quick operation. So, you know, I want to start listening to an audiobook, like Cortana, start playing that. I want to listen to some music. I want to see some movies on Netflix, or I have some questions about, like, you know, how my stocks are doing specifically. So one scenario is question and answer. I asked Cortana some questions. Your application has the data, you figure that out, and you give the results back to the user. The second is for quick task completion, whether that's for entertainment or for productivity.
Does Cortana has kind of default words, like you know, play or skip or pause and that kind of thing? That would be kind of common words for, you know, using that wherever the browser is or player is or slash or application is. So do you have kind of intention of having that kind of common words to operate the application running on the Windows?
Do you want to take that or should I? So I think you're asking about common words that Cortana has in the grammar that might conflict. So in one of Adina's slides, she had the list of words such as call, open, text. Those are likely to conflict, but there's no guarantees about one behavior or another, because a lot of this is machine learned, and you know, the recognition happens in a non-deterministic fashion. So the guidelines that we've shared is ways that you can reduce that likelihood. So the more specific you make the scenario, so for example, if you say Viber, text this contact with these details, that's a lot less likely to conflict, because we understand that the specific command is directed at Viber.
So that goes back to that ask to make the listen phrase to be phonetically rich and to not be confused with other words. I think if your question is, can we use, or will there be words that will be likely used by multiple applications? And he's not talking only about Cortana reserved words, but words that, you know, more than one application might find compelling for their scenario. And how do we make sure that these are not confused?
So in this scenario, this is why we recommend that the application name really be your application's name. So please don't use words like find or search or launch as your app name, because that's not what it is. That's why we recommend that the application name is your application name or reference to it, and is relatively unique and associated with your brand. That helps Cortana and the user disambiguate and be very specific about what they want handling what scenario.
Okay, thanks.
Thank you.
For the case where you do not have a custom grammar and you don't have internet connectivity, are you attempting to figure out what the user is asking for, or will they not get that?
Let me rephrase the question and ask you if I did a good job at it. So I think you're asking how much of this stuff is going to work offline, right?
Yes.
Okay. So in the offline scenarios, as Adina mentioned, the dictation of generic phrases uses the Microsoft speech recognition services, so those won't be available. But if you're doing a command such as, when's my trip to Las Vegas? And Las Vegas is in the phrase list, all of that is in the local grammar and would be recognized, and your application, whether in the foreground or in the background, would get launched. So the only scenarios that wouldn't work are the ones that depend on a phrase topic.
If there's is there a case where you have connectivity, but there's a good match, you know, some simple phrase, you know, find my trip, will it still go to the back end anyway? Could you give an example? Would there be a time when you would short circuit the part where you would you would hit the back end even though it's available?
I see. So that's really an implementation detail question, and it really depends on what the performance of the system is like overall. So if we're trying to optimize for the user perceived latency, and we have some metric for determining that the local confidence is high enough, then we may. But ultimately, the contract we present to you is that we will use both cloud recognition service and on-device in a fashion that is abstracted from third-party applications, and we will select whichever one is best at that time.
So you're saying it's none of my business?
I'm sorry?
It's none of the application developers' business. I mean,
It is nothing we would
that's
like you to
okay.
worry about because the implementation may change. But it isn't. But having a connection to the service is not required unless you're taking a dependency on phrase topics.
Is there any recommended practice for user credentials, passwords, usernames?
In relation to?
Like, for instance, if I had a banking website and I wanted to pay a bill.
I think the best way to go about that is to have the foreground application authenticate with the service, save the credentials, and share the credentials with the background service. The background service will never use Cortana to collect your credentials.
Yeah. So remember, we really want you to respect the user's privacy. And in general, we should avoid getting passwords or information like that over the speech channel with Cortana. If the user is authenticated with your application, and let's say you persist those for a period of like a week or so, if the user happens to ask those questions to your application and your background task has its credentials, then yes, I think it's safe. But otherwise, we don't recommend you prompting the user, all right, what's your password for your Fidelity Bank account?
And worst case, if the credentials expired while you're trying to use this in the background task in Cortana, you can call request launch async to launch the application in the foreground and re-authenticate.
Or you could call report failure async with this specific message saying, I'm sorry, it looks like you haven't used our app in a while. Please try this in the foreground and then come back.
Thank you.
Any other takers? All right, well, thank you for attending. We'll still be walking over to the insider area. If you have further questions, please feel free to follow along.